All right, we are going to simplify. This should be something along the lines of, in a question, simplify the following rational equation. Okay, and we are going to do it as follows. So there's really no one right direction to go in order to get to the same tippy top of the mountain. You could take a number of different paths, but one thing that may speed things up a little bit is to just look for patterns in things. But when you're in the middle of a test, you don't have that much time to really think about, can I play around with this or that? If you get stuck, then you can start to tinker. But in the meantime, what I recommend doing is when you have something that looks like this, my recommendation is going to be check to see if you can quadratic factor anything. So quadratic factoring, check for that first. Because when you simplify the quadratic, so we've got two of them here, as you can see. When you simplify the quadratic, then you often can see patterns as it relates to other things maybe you can cancel them with. So we'll do that first, then we'll come back possibly to this over here. How do we simplify quadratics? We'll kill two birds with one stone, so to speak, and start with this part. So maybe I'll do over here, I'll take this space to simplify the quadratics down here, and then we'll continue the rest of the simplifying over here. So what we're going to do is for ones where the front coefficient is not 1, so this is not n squared but 2n squared, this is this is 6n squared down below. No, by the way, you do not ever try and start simplifying straight ahead. These are not factors yet because they are being added and subtracted to one another. Students fall for that all the time. Don't do that. So what we're going to do instead is we're going to multiply these two together. We're going to factor this. We're going to break this into factors like this, but they won't look like this. We'll have numbers in between those brackets that make sense. And then we can start to do some canceling. So we're going to multiply 2 and 36, and that's going to give us, 72? So we'll have 72. And all we're going to ask is that simple question from before: what two numbers can I add together that are factors of 72? Multiplying would give me 72, but are going to be equal my middle term, which here is negative n. So I'm just going to say -1, actually. I shouldn't say the middle term because the middle term is negative n. I should say equal to the negative coefficient, to the middle coefficient, the coefficient of the middle term. So -1. So what can we put in these two brackets, in these two boxes? I should say we don't have brackets yet, but these two boxes, we will have brackets momentarily. Well, two things that make 72, these are going to, if they're going to come together and make a -1, they better be pretty close together. If I did say, for example, 72 and 1, even if I could find, a way of adding them together so I'm left with a negative, they are nowhere near the small size that -1 is. So we need those two terms to be closer together. Hopefully you thought to use 8 and 9. So let's do that. 8 and 9. I just realized I didn't give myself a lot of space to do it. 8 and 9. But one of them's got to be negative. Obviously, if they're both negative, they'll be too big. I hope you can see why. This has got to be a -9. -9. All right, so added together gives -1, and multiplied together, this will be a -72. Sorry, if I thought about that well, I would actually, I'm going too fast here, but I would be doing 2 times -36. Technically, it would be -72 that I'm factoring, not just 72, but moving fast, sometimes this is what people do, and they make mistakes, and I almost made one, but I think I would have been okay in the end. I would have noticed it, as I did. Okay, so moving on. So what we need to do, again, we can't just jump to then putting our brackets in and doing this because that front coefficient is not n squared. It's a 2n squared. So let's rewrite this down here and break up that middle term and see if we can find the pattern then. And I'm going to do it in a certain way that makes sense to me. I'm noticing right away that 2 goes into 2n and 8. So I'm going to do that one first. Yes, 2 goes into this too, but that doesn't matter, as you'll see in a second. I also want to note that -9 will go into -36 4 times. So let me break it up this way. I'm going to break it up this way. Oops, this is a squared. Sorry about that. That should be 2n squared, 8n minus 9n. So we just broke up the middle term. into these two parts. This is what's going to help us factor the quadratic expression here. And now we're going to stick negative 36 back on here. And now comes the magic. We ask ourselves, what common factor do these first two terms have? Well, they both have a 2 and an n. That's 2n squared. So they have an n in common as well. I'm going to drag out the 2n. That's going to leave 2n times what equals 2n squared. It must be an n. And then 2n, if I drag what times 2n gives 8n, obviously it must be 4. N plus 4. And in this next expression, I'll show you a little trick to make this part actually faster. But let's continue as it is. Negative. So let's go on and figure out, well, I don't know if it's negative yet. Let's figure out if it's going to be negative. Should I drag out a positive term or should I drag out a negative term from these? Well, here's a big hint too. I need it to ultimately be the same as that. Right, that has to be the same. Whatever I factor out of here, I want to be left with the same thing because I'm going to be double factoring, which will make sense hopefully in a second if you don't already know what I mean. So let me drag out a negative something. How about negative 9? Because negative 9 times n would give negative 9n. So, and I want that to just be an n, just like it is over here in my little box. So I'm going to do negative 9. So that'll leave me with n. And lo and behold, negative 9 times a 4 would indeed, a positive 4 would give me a negative 36. So this is a good thing to be factoring, and now my two boxes match. I like that. That means I can take them both and factor them out of here. Just like if this was like, just imagine this is a great big A. Great big A. Well, they both share A. Both terms here share A. So I could just factor A out. But instead of a big A, I'm just going to go on and factor out these boxes that I made. So now we've got n plus 4. And what I have left is, of course, 2n minus 9. 2n minus 9. Okay, and that's how we have just now simplified these. So let's rewrite our thing here. Let's rewrite this. I'll go a little faster here. Whoops. Kind of under the gun here. I've got a class coming up before too long, and I want to make sure that I get to that on time. Oops, I'm not going to put 2 in anymore. I'm going to put I'll go on and put them in parentheses still. N plus 4 times 2n minus 9. Apologies in advance if any of these are kind of a bit small. Okay, now we got to do the same thing down here. We got to do the same thing. So let us, let's see, let's just put a big break between the, or, whatever. I'll do that. Okay. Same thing though. Okay. Same thing. So we're going to do 645. I'm going to go a little faster this time, and I'm going to show you how to actually kind of skip a step if you feel confident with this. If you don't feel confident with what I just did here, go back and review it immediately so that this next part makes sense. So all I'm going to do again is I'm going to say 6 times 45. 6 and 4 is 24. 6 and 5 is 30. So that'll be 270. And there's no negatives in there, so it'll be a positive 270. Same question. What? I'm not giving myself any room to write here, though. So let me do this. Okay. What plus what will give me the middle term is negative 37. All right, well, there's a big clue in itself. They must both be negative, right? Because they have to add up to a negative number, but they have to multiply and cancel the negative to get a positive 270. So we know they're both going to be negative. And I don't have to think too hard about this, really. I see 27, 37, boom. What relationship do they have? Well, this is if I were ignoring the 0 at the end, they'd be 10 away from each other. Well, if I did a negative 27 and a negative 10, yes, indeed. Negative 27 minus 10 would be negative 37 and multiply together to give a positive 270. We've got our terms. So I'm going to break them up again, just like I did before. So now we've got 6n squared minus, I'm going to think about this. 6 doesn't go into 27, but both 6 and 10 are even. I'm going to hedge my bets here and go with negative 10n next. Minus 27n. I can't forget that those are n's. Those are my middle terms being broken up into 4 into two pieces. These two pieces, not 4. All right. So simplifying. Now I'm going to do that skipping of a step. I'm going to go on and form my boxes, my brackets here, and all I'm going to do is I'm going to fill them in with what I know. So I know that I can pull a 2 out of here and an n out of there. So 2n. And yes, I could go on and start to do it the way I did up here, where I put the box right next to it and figure out what is left over after factoring this part. I'm going to not do it over. I'm not going to do that over here. I'm going to do that over here because I already know ahead of time, right, that's what's going to be left over. It could be here or it could be on the, it doesn't matter if it's on the left or the right, does it? So instead of worrying about pulling those out afterwards, let me just go on and write what's left over on the right-hand side here. So I'm going to have, what am I going to have left? I'll have 3n minus 5. By the way, quick check. Look at that. I'll bet there's something going to be able to cancel there, especially since they occupy a top and a bottom position. So we'll come back to that. So 3n minus 5. So I want this now, if possible, to look like 3n minus 5, or else I've ruined my entire experiment. Let us see. If I pull out what if I pull, I need to pull out something negative because I need to be left with 3n, so it must be negative 9. Negative 9. Let's try that. So if I do negative 9 times 3n, I will get negative 27n. And if I do negative 9 times 45, no, sorry, times 45, times negative 5, I will indeed get 45, a positive 45. This is gold. That's what we want. So now we rewrite up here 2n minus 9, 3n minus 5. And I've got everything I need. Now what I can do is I can change the way this looks, see if I can find any further patterns here to then start to cancel some stuff out. Hopefully you can see that already these cancel out. Those cancel out nicely. So all I really am going to have, let's see, if I do some factoring, let's come back to the top part in a second. So this is equal to that. Even though this is an expression, we're saying this is all equal to this, right? It's all just a simplified version of that. If I pull out 10, I'll get n minus 2. And then let me rewrite what's up top here. All I've got left is n plus 4, and then down below 3n minus 5. Well, I've got a 5 minus 3n here. Is there something I can do with that? Absolutely there is. What if I pulled a negative out? If I pulled a negative out, I'll write it down here. By the way, if you're not sure what we're doing right now, what we're doing is now simple, what I call simple factoring. Now we're just factoring out. Once all the quadratic factoring's done, now we can do some simple factoring, play around, see if we can figure out what we can annihilate given the factors that we found in here. We already annihilated one pair. We will be able to do at least one more. So if I have 5 minus 3n and I pull out a negative, so that would be making each of these terms the opposite in signage of what it currently is. 5 will become negative 5, and this will be a 3n, a positive 3n. But that means I could rewrite this, right? I don't have to do it in this order, so it would be also equal. Can't seem to write an equal sign today. There we go. It would also be equal to negative 3n minus 5. Pretty cool. As long as I have my parentheses here, if my parentheses are here and my minus sign is outside of them, then these are equivalent. These are the same thing. So let me rewrite that over here as negative. I'm going to put just the negative on the outside, 3n minus 5. And I can keep the parentheses there, or as is common, maybe I'll do that just for convenience sake, but as is common, this is outside of the fraction altogether, so I don't really have to worry about that. Look at that. We've got more cancellations to make. Bam, bam. Okay, so all we've got left over now is negative n plus 4, and I'm just going to go on and redistribute that. 10n minus 20. And this is where people they'll think too hard and they'll start to maybe make some further mistakes. It's okay to see patterns. It's okay to see, oh, well, these are all even numbers. I can pull out a 2 maybe, and then it would be 1/2 n. And yeah, don't don't complicate things too much here. That could end up I mean, you could, if you did it, here's what you would see. Let's just do it and see what happens. Maybe I'll change my mind about it, but I doubt it. So if I pull out a 2 from the top and the bottom, right? A 2 from the top and a 2 from the bottom, I would be left with 1/2 n plus 2, and I would have a 5n minus 4. And I don't find this particular any prettier than, and this of course just cancels out to 1. So that's just now equal to negative, this 1/2 n. I don't find this any more useful or prettier than the one we already have. So for me, this is kind of a waste of time. I should probably be spending this time, instead of doing what I have in green here, I should probably be spending this time working on another problem. So I would leave it here as our answer. But if you are so inclined, feel free to play around, and maybe this is what your teacher wanted. Maybe your teacher wanted you to go and make a fraction out of a fraction, like make a bigger fraction out of the fraction. I don't know. That's not what I would expect, but I don't know your teacher. Maybe find out. If you have a similar problem and you have the chance to get in touch with your teacher, ask them and get that squared away.